Hey everyone, Jared VK3VL here, and today I want to use my new Fieldtech FY6600, a very cheap signal generator which is capable of generating sine waves up to 60 megahertz, to demonstrate the differences between a T-connector, as seen here, we're all familiar with them, and a proper power divider or proper antenna splitter. This one, I'll see if I can hold it up to the camera bit more maybe, is a mini circuits power splitter model ZSC, Zulu Sierra Charlie, -2 plus, and it's rated from 0.002 to 60 megahertz. Now that is a power splitter. What this does is it actually guarantees that each device on the 2 ports here, that's your input, gets half the signal or half the power, and it actually also guarantees that device on port B doesn't interfere with device on port A. So it also isolates the devices from one another. Clearly there's no such magic going on here. Whatever's plugged into here and whatever's plugged into here, that actually becomes a parallel circuit. So if we think of resistors in parallel, the resistance or impedance in the case of receivers becomes the combination of the two. So if we have two ideal 50 ohm nominal receivers and we plug one into each end of a T-connector, our antenna is presented with 25 ohms of impedance. On the other hand, with this, if we have 50 ohms there, 50 ohms there, or pretty much anything on either side, as you'll see, the antenna will still see 50 ohms here. So why do I want to show you this? Because I want to ask a very important question of the MFJ-1708SDR transmit receive switch. Now, what this promises to do is allow you to have a SDR dongle hanging off your normal rig for use as a second receiver or a band scope, and whenever you go to transmit, so you got push to talk there, it'll disconnect the SDR and basically have only the radio connected to the antenna. So I want to decide and do some tests to see whether this is actually nothing much more than a switched T connector, or whether this is in fact more like a mini circuits power splitter. Now, bear in mind this isn't a look. They're cheap for what they are, but this is a reference grade commercial spec power splitter. You can go and download the graphs and all that sort of thing. So I wouldn't expect this to ever approach the performance of that, but this is sort of the ideal, and this represents basically the worst. So let's get to work. Okay, what I have here is I've got the Fieldtech plugged into my Signalant SDS 1102 CNL, or Charlie November Lima oscilloscope. It's a really basic entry-level digital storage oscilloscope, DSO. They just call them oscilloscopes now. They used to call them DSOs when you could still buy analog models. And this has a nominal amplitude of 5 volts. That 5 volts is only ever into the amplitude on the Fieldtech. Whatever it says there is only ever into essentially an infinite impedance. On a 50 ohm load, I've got a 50 ohm resistor on my little splitter here. The peak to peak voltage is actually 2.6 volts. So that's one of the limitations of this instrument, is that the amplitude is into an infinite impedance. It's not into a real load. You do have to use something like a scope to set up your amplitude when you're using something like this, but it will, as the scope says, generate a 7 megahertz signal. So that's all I want it for and all I need it for. So let's have a look. As you can see there, I've got that directly plugged in. That's equivalent to an antenna plugged into a radio, and we're getting between 900 and 900 millivolts root mean square of voltage. Now, unfortunately, I can't tell you the power. This doesn't do RF. It doesn't have an RF ammeter in it that I know of, but that's the power, and that's really all we need to know for this demonstration. So what we're going to do is we're now going to insert a T connector. insert the T connector, so excuse my hands. We'll put our reference load here down on the bottom. And we can see with the T connector plugged in, we still have 900 to 920 millivolts RMS. So the fact that the other end of the T connector is unloaded has very little effect at 7 megahertz. It's not causing any issues. It's essentially infinite impedance, and all the power is getting transferred to channel 1. Now, let's see what happens if we plug channel 2 in. Nothing much has changed. You can see both the waveforms are overlapping. Don't think I can change the, can I? I can change the vertical position, but both the waveforms are overlapping. I'll leave it like that for the moment, but you can see that they're essentially identical. And so by plugging in the second channel, we haven't really changed much. We've actually dropped about 40 millivolts. So there has been a bit of a hit, but because the oscilloscope is a relatively high impedance, or near infinite impedance instrument, it hasn't detracted from most of the power being dissipated across that 50 ohm resistor. Now, I've got two other resistors here. Now, I have previously tested them to see how they perform at 7 megahertz and whether they're inductive or anything, and they're pretty much in line with my Diamond DL50A dummy load, so there's no issues there. These carbon film resistors tend to be pretty good. Let's chuck another 50 ohm in, and I'll just hold that down, and we can see that both the voltages on both channels have gone down. Now, they've gone down to 600 millivolt on both channels, so from 900 to 600. I'm sure if you go and do the math, you'll find out that the power is evenly distributed. V equals IR applies here, guys. You've got RMS of 600 millivolt across 2 50 ohm resistors in parallel. Should be easy to prove with a little bit of math that the same amount of power is being distributed to each channel. Once again, I'll just show that, they are identical waveforms, and we know because of the same resistance, identical power is getting distributed. No problems there. What happens, for instance, if one of our transceivers or our SDR dongle, maybe a cheap SDR play, is actually a different impedance? No, sorry, not a cheap SDR play. I mean, they're a relatively good instrument. I quite like my SDR players, as you know. I mean, a really, really, really cheap. I'm used to describing SDR players as cheap because I think they're a bargain. I mean, a really cheap Realtek SDR. So those RTL-SDRs that you pick up for $10 US, they're 8-bit dongles. People get them to work. They usually tap the first IF of their transceiver. What would happen if we were to connect that up to the other side of the T connector? Well, those devices were designed for a 75 ohm impedance because they're made to receive TV. So I've got myself a 75 ohm resistor here. Let's plug it in. Now, at first, you'll see that you'll see that both of the first thing you'll see is that both of the channels, channel 1 and channel 2, both have a voltage of 660 millivolts going across them. And you might think that there's no problems with this arrangement. Each radio is getting an equal bit of signal. It doesn't matter that one is a higher impedance than the other. No big deal, right? But remember, this is a parallel circuit. So what's actually happening is the 50 ohm resistor, is getting the lion's share of the signal, while the 75 ohm resistor is actually getting less of the signal. Now, that mightn't be a bad thing. In the case of a Realtek SDR, it means that instead of losing the ideal 3 dB that you would, what am I trying to say? Instead of the ideal 3 dB split that you'd normally get, your Realtek SDR is only going to take a little bit of the power and leave the rest to your radio, so you're not going to get the huge huge, the half S unit loss of power on your main receiver. Maybe you think that's a bad thing, but what it does mean is that the Realtek SDR won't be very good as a second receiver. It's not getting the same amount of power. Now, I'm making assumptions here. I don't know whether a Realtek SDR is 75 ohms. A lot of receivers have a nominal impedance, and that's they're nominally 50 ohms, but they can vary, and they can vary by frequency. So it's not a good situation to be in to have a receiver, to have a situation where you've got two receivers in parallel. Not only because you can never really be sure which one is getting the lion's share of the power and therefore has the best ability to produce, to receive the signal, but you've also got the problem of the fact the receivers can interact with each other. If one receiver has birdies, for instance, and your better receiver doesn't, now it's quite common for a cheap Realtek SDR to have birdies, those birdies will suddenly be introduced into your main receiver. So there are limitations to the T-connector that don't go beyond just sharing the power, and they do not share the power equally. The majority of the power goes to the lowest impedance receiver. I've got a 33 ohm resistor here. Put that in, if I can get the holes right, and you can see we've gone down to 500 millivolts there. So on both channels. So channel 2, if you do the math, is getting the lion's share of the power. Channel 1, which probably being, you know, your nominal 50 ohm high quality ham radio gear, is, you know, it's losing almost an S point. So your cheap dongle is getting all the, you know, not all the signal, but the good part of the signal, and your actual radio that you're listening to and wanting to use is suffering. And so that's really where a T-connector is a terrible choice of a terrible device and a terrible choice for splitting a signal. And that goes far beyond the fact that you have to actually unplug the SDR or disconnect the SDR in some way when you want to transmit. So let's see what happens when we use a real power splitter. Now this one is guaranteed to give each channel 3 dB irrespective of their impedance. Sorry, wrong cable. What have I done with the correct one? Mysteries of the ages. Here it is. So, the middle is the source. See there. Plug that in. Okay. We'll plug our reference 50 ohm into channel 1. And you can see here, straight off the bat, even with nothing else plugged in, we're getting 600 millivolts RMS. And that's what we got when we had two 50 ohm resistors plugged into each side of the T-connector. So straight off the bat, we know that this is giving half the power, or 3 dB of the power, to channel 1, even though channel 2 has an infinite impedance. Let's plug something into channel 2. Now this has nothing connected at the moment. Look at that. Now, if I was to go and measure that, you would find that that's probably well above the 900 mark. That's almost equivalent to, let's see if we can measure it. I'll try and figure out how to measure it again. Let's have a look. Channel 2, no. Oh, turn that off. Measure. Yeah, I know, that's what I want. I want to change it. No. Well, anyway, the point being is, I won't distract myself with that, is that channel 1 is getting its half, and channel 2, because it's got a higher impedance, is allowed to float to whatever voltage it needs to deliver the same amount of power, or a similar amount of power. Now in this case, I don't think it's delivering the same amount of power to both channels. If I actually could figure out how to measure it, well, let's give it a rough estimate given the divisions. We've got, let's have a look here, 1, 2, 3, 4, 5, 6, 7, 7 divisions, 7 times 5. Math's never my strong suit, 35. So we've essentially got 3.5 volts peak to peak, whereas the other channel has 1.8 volts peak to peak. So it's roughly double. So, which, you know, is essentially an infinite SWR, as you'd expect, is roughly double the power. So let's have a look here. Let's see what happens when we chuck 50 ohms in. They very almost match each other. Actually, was that the 50 ohms? I don't think it was. No, it wasn't. This one's the 50 ohms. I think it is. Getting my resistors mixed up here. So let's make life easy, shall we? Where's my 50 ohm resistors? Yep, that is the 50 ohms. So if we push that down there, we can see that they're not identically split, but they're very, very close. So in this case, our mini circuit splitter, and I've got it round the wrong way, it is splitting the power roughly, almost perfectly, between the two loads. Now let's say we go and put, I think this is the 75. I'll have to confirm it. This is where I wish I'd paid more attention to reading resistor color charts. Nope, this is the 100. Let's chuck the 100 ohm in. Once again, you can see that there's a difference, but there's not a huge amount of difference, as you wouldn't expect. But the point is, neither channel is interacting with each other, and neither channel is stealing all the power. The power is being adequately divided, and that's why you can see different voltages. Because you've got different resistances on each side, they're no longer in parallel. The splitter is actually allowing the voltages on each side to differ, so that the same amount of power, even though they've got different currents, can be delivered to each load. And that's ideally what you want to split an antenna, because you never know whether your receiver is going to be 100 ohms in impedance on a frequency, your second receiver, whether it's going to be, let's have a look again, you know, I think that was the 50, near 50 ohms. You never know whether it's going to be, I think this is the 33, or maybe this is the 50. No, that's the 50. You know what I mean? So you're always, as I said, it's a nominal value. Receivers are nominally 50 ohms. You want a nice splitter like this that allows the voltages to change so that each receiver gets the same share of power. I can't emphasize that enough. Anyway, now that I've covered why you need to use a proper antenna splitter, and that is to divide the power evenly, as well as isolating the receivers from each other so they don't share birdies. There's about, about 30 decibels of isolation in this particular mini circuits device. Let's see what the MFJ does in this situation. And this is really going to be the big test as to whether you should rely on an MFJ during a DXPedition where you need, or where you're trying to work a really weak station and you need every last bit of the received power coming out of your antenna to go into your best quality receiver. Should you use an MFJ-1708 during that time or not? Let's find out. So, is this going to be a T connector, or essentially a switched T connector with the push to talk, or is it going to be a power splitter? Now the way we'll find out is if when I plug the signal source in, if both channels read the same voltage, it's a T connector, a switched T connector. If each channel is allowed to float to the voltage it needs for the power to be evenly split, it is a switching device with a power splitter in it, and that would be a very good device. I would have that plugged in all the time, no matter what, essentially, except for the very, very weakest of signals where even that 3 decibel loss, you know, is something that could be an issue with copying their signal. But, you know, that's very rare. On the other hand, as I've stated, if it's a T connector, you don't want to have it plugged in when you're trying to copy a station that's only a little bit above the noise. You'll actually find that by removing it, by disconnecting your SDR, only having your primary main receiver plugged in, your proper ham radio, not your Realtek dongle or whatever, or, you know, even any second receiver, essentially. It doesn't have to just be a Realtek dongle. With a T connector, any second receiver is going to limit your ability to copy a weak signal. So let's find out. Let's get this thing connected up. Let's see, we'll disconnect that lead. I have two of these nice PL259 to band C adapters. They're genuine Amphenol, at least one of them is. I have just a simple little patch lead here. Plug in. We will apply the power now first to be nice. I don't know whether you need to or not, but we will do it. You can see the red lights come on. And let's connect the signal up. Well, don't mind that. Sorry about that. Cables move around. Okay, so on the radio side, I'm going to plug in my 50 ohm reference. And you can see we're getting 900 millivolts. That reminds me of the 900 millivolts I got when I was using a T connector and I plugged that load in. So that's immediately making me a bit suspicious. But let's plug in the second channel and find out for sure. There you have it. Both channels are tracking the same. And this is where I don't need to know the resistor value. And I shouldn't put my hand in the way. Irrespective of what resistor I put in, both channels track the same. And I'll make that a little bit more obvious. I'll just increase the offset of one. Take that offset away. Both channels are tracking the same. That means this device here there we go. Sorry about that, guys. I had a bad connector, but wrapping things up, what you've got here is you have essentially a switched T connector. This behaves exactly the same as a switched T connector, and my advice is, and I'll just disconnect everything now because we don't need it anymore. I would only use one of these in the situation where you've got strong signals and where you really want a pan adapter. I'd only use it with a high quality SDR such as an SDR Play. If you use it with something like a Realtek RTL-SDR, the $10 things you got off eBay, you're guaranteed to degrade the heck out of your primary receiver. You know, it might have its use cases. Personally, I would save my money for, you know, an ICOM 7300 if I really needed a scope. I don't like the product. I think it's a lot of money to pay for what is essentially a relay that switches on push to talk. It does look nice. It will do the job, but when you're using one of these, it's the same as having a T connector in place. It's not the same as having a proper power splitter, and you will degrade the performance of both receivers. They're not isolated from each other. The birdies on either will talk to each other. The noise on each other, the phase noise on each will talk to each other. One will get the lion's share of the signal at times. If you do decide to use these, please only use them to check out your friend's signal on the RAG TuneNet when using an SDR play or other high quality SDR receiver or second receiver. Please don't use them for chasing DXPeditions. You'll hurt your chances. Anyway, this is Jared of VK3 Bravo Lima. I hope I've shown you how even a cheap, imprecise instrument can help answer questions that are pertinent to hams, and I've provided some good advice regarding purchasing. Thumbs down, MFJ. It wouldn't have killed you to put some sort of buffer in there so that a transformer, this is essentially a transformer, in this device so that it didn't degrade the performance of your primary receiver any more than the 3 dB that it had to. There's Jared at VK3BL saying 73 for Rate My Radio, and save your money, guys. Cheers.